Good afternoon, guys. Welcome back into my channel. So in this lab and lecture, we're going to talk about BGP. So, and at the end of this lab, we're going to make a configuration on we're going to configure and verify the eBGP. So this is the ebook of this of the CCNP and Encor search guide straight from Cisco. So you see, if you follow here, you see it says in chapter 11 it talks about BGP. So this chapter covers the following subject: BGP fundamental, basic BGP configuration, routing, summarization, and multi-protocol BGP for IPv6. So RC 1654 defined border gateway protocol as an EGP standardized path vector routing protocol that provides scalability, flexibility, and network stability. When BGP was created, the primary design consideration was for IPv4 inter-organization connectivity on public networks like the internet and on private dedicated networks. BGP is the only protocol that used to exchange network on the internet, which has more than 780 million IPv4 routers and continues to grow due to the large size of the BGP table. So BGP does not advertise incrementation, update, or refresh network advertisement as OSPF and ISS do. BGP prefers stability within the network as a link flap could result in route computation for thousands of routes. So this chapter covers the fundamental of BGP path attributes, address familiars, and inter-routing communication. So BGP configuration, route summarization, and support for IPv6. So in chapter 12, advanced BGP, explain the common scenario. So let's go ahead and so it says BGP fundamental. From the perspective of BGP, an autonomous system, AS, is a collection of routers under a single organization control using one or more IGPs and common metrics to route packets within the autonomous system. If multiple IGP or metrics are used within the AS must appear consistent to external ASs in routing policy. An IGP is not required within an AS, and an AS could use BGP as the only routing protocol. So autonomous system number. An organization requires connectivity to the internet must obtain an autonomous system number ASN. So ASN were originally 2 bytes, 16-bit range, which made 65,535 ASN possible. So due to exhaustion, RFC 4893 expanded the ASN field to accommodate 4 bytes, 32-bit range. This allows for 4,494,467,295 unique ASN provide quite an increase from the original 65,535 ASN. ASNs. So 2 blocks of private ASN are available for any organization to use as long as they are never exchange policies, publicly on the internet. ASN 65,512, that's 65,535 of private ASN in the 16-byte ASN range in this number here. Now, the Internet Assigned Number Authority, which is IANA, is responsible for assigning all public ASNs to ensure that they are globally unique. IANA requires the following item when requesting a public ASN: a proof of publicly allocated network range, a proof that internet connectivity is provided through multiple connection, and need for a unique routing policy from providers. Now, in the event that an organization cannot provide this information, it should use the ASN provided by the service provider. Note, guys, it is imperative to use only the ASN assigned by the IANA. The ASN assigned by your service provider or a private ASN using other organization ASN without permission could result in traffic loss and cost havoc on the internet. So path attributes. So BGP use path attribute PA associated with each network path. The PAs provide BGP with granularity and control over the routing policy within BGP, and BGP prefix PA are classified as follows. So it's well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. So loop prevention, if you go down here, the AS200, AS300, address family, interrouting communication. So some network engineer refers to multi-protocol BGP as MPBGP, and other network engineer use the term MBGP for both refers to the same thing. Okay. So note, BGP neighbors connected to the same network use the ARP table to locate the IP address of the peer. Multiple hop BGP session requires routing table information to find the IP addresses of the peer. It is common to have a static route or an IGP running between BGP neighbors for providing the topology path information to establish the BGP TCP session. A default route is not sufficient to establish a multi-hop BGP session. So BGP can be taught as a control plane routing protocol or as an application because it allows for the exchange of route with a peer that is multiple hop away. BGP routers do not have to be in the data plane path to exchange prefix, but all routers in the data path need to know all the routes that will be forwarded through them. So we have the internal BGP and the external BGP. But the configuration today is going to be about the external BGP. So a session established with the BGP router that are in the different AS. So service provider that provide the transit connectivity, enterprise organization or consumers, and should not provide transit connectivity between autonomous systems across the internet. Okay, guys, so We got the BGP neighbor here. It says BGP form a TCP session with neighbor routers called peer. BGP used the finite state machine to maintain a table of all BGP peers and their operational status. The BGP session, they report the following states. So idle, connect, active, open sent, and open, confirm, and establish. So it explains everything here in this stage. So this is important. If you want to get a copy of this book, I'm going to leave a link down there so you could have it. So let's jump into the little lecture that I prepared here for you all. So what is BGP? If you may have this question. Well, Border Gateway Protocol, BGP, is the postal service of the internet. When someone drops a letter into a mailbox, the postal service processes that piece of mail and chooses a fast, efficient route to deliver that letter to its recipient. Similarly, when someone submits data via the internet, BGP is responsible for looking at all the available paths that data could travel and picking the best route, which usually means hopping between autonomous systems. So BGP is the protocol that makes the internet work by enable data routing. When a user in Singapore load a website with origin server in Argentina, BGP is the protocol that enables that communication to happen quickly and efficiently. So what is autonomous system? Well, the internet is the network of networks. It is broken up into hundreds of thousands of small networks known as autonomous system, ASs. Each of these networks is essentially a large pool of routers run by a single organization. So if we continue to take off BGP as the postal service of the internet, ASs are like individual post office branches. A town may have hundreds of mailboxes, but the mailbox in those boxes must go through the local postal branch before being routed to another destination. The internal route within an AS are like mailboxes. They forward the outbound transmission to the AS, which then use the BGP routing to get these transmission to their destinations. So the diagram above illustrated a simplified version of BGP. In this version, there are only 6 axes on the internet. If AS1 needs to route a packet to AS3, it has 2 different options: hopping to AS2 and then to AS3. So AS2 to AS3, or hopping from to AS6, then to 5, to 4, and finally to 3. So AS6 to 5, to 4, to 3. So guys, in this simplified model, the decision seems straightforward. So the AS2 routes require fewer hops than the AS6 route. And therefore, it is the quickest, most efficient route. Now, imagine that there are hundreds of thousands of ASs and that hops count is only one part of a complex route selection algorithm. That is the reality of BGP routing on the internet. So the structure of the internet is constantly changing, with few systems popping up and existing system becoming unavailable. Because of this, every AS must be kept up to date with information regarding new routes as well as obsolete routes. This is done through peering session when each AS connect to the neighboring ASs with a TCP IP connection to the purpose of sharing routing information. Using this information, each AS is equipped to properly route outbound data transmission coming from within. Now, there's where part of our analogy fall apart. Unlike post office branches, autonomous systems are not all part of the same organization. In fact, they often belong to competing businesses. For this reason, BGP routes sometimes take business consideration into account. ASs often charge each other to carry traffic across their networks, and the price of accesses can be factored into which route is ultimately selected. So who operates BGP autonomous system? So ASs typically belong to the Internet Service Provider, which is the ISP, or other large organizations such as tech companies, universities, government agency, and specific institution. As AS wishing to exchange routing information must have a registered autonomous system number. ASN. The Internet Assigned Number Authority, IANA, assign ASN to Regional Internet Registry, which is RIRs, which then assign them to ISP and networks. So as I said, these are basically what we've seen already on the book. So let's just talk about what is the difference between external BGP and internal BGP. So routers or exchange and traffic is transmitted over the internet using external BGP. So autonomous system can also use an internal version of BGP to route through their internal networks, which is known as the internal BGP IBGP. It should be noted that using internal BGP is not a requirement for using external BGP. Autonomous system can choose from a number of internal protocols to connect the routers on the internal network. So external BGP is like the international shipping. There are certain standards and guidelines that needs to be followed when shipping a piece of mail internationally. Once that piece of mail reaches its destination country, it must go through the destination country local mail services to reach its destination. Its final destination. So each country has its own internal mail service that does not necessarily follow the same guidelines as those of other countries. Similarly, each autonomous system can have its own internal routing protocol for routing data within its own network. So guys, I know it's a long video. It's a long lecture, but this is very important. You have to understand BGP. Even for the level of CCIE, people are still learning about BGP. So you could come here and says border gateway protocol means, see here, like border gateway protocol, it refers to a gateway protocol that enables internet exchange routing information between autonomous system, yes, as the network interact with each other. So there are ways to communicate. This is established through peering. So it's the same thing we do. All right, so enough with this lecture. Why don't we go ahead and follow up? Yeah, it's very important. So because BGP runs over transmission control protocol, which is TCP, it is compatible with the rest of the internet, which is used TCP for communication. So TCP makes sure data packets get sent and delivered across network. So BGP is also interfaces well with secure socket layer, which is SSL, a virtual private network, which is VPN, and transport layer, which is TLS. I mean, transport layer security, which is TLS. So BGP converse network bandwidth. So like I said, these are very important topic. I put together this lecture. I hope it's very helpful. I hope you take your time to just browse through this and understand this concept, read them and know about them, because it's not important just to know how to configure BGP, but it's to be able to explain the technology and be able to convey the knowledge into someone and make them understand what is BGP. So enough with this talk. Let's go ahead and start configuring. So we have this lab simulation today. Let's see if we can make this big. Oh, no, it's too big. So let's go back to its original size. So it says that to configure and verify eBGP, which is external border protocol. I mean, it's external border gateway protocol. So we go. So here's the lab. Here's the addressing table. We get the ACMA one or the corporation, ISPN3 one, ISPN3 two, get PC0, laptop, and laptop 0, laptop 1, and server. So on part 1, it says that the Acme hiring an ISP provided a a connection to a partner company, call it other company. The ISP has established a network reachability within its within its network and the other company. So you could look at here what we got to do and different tasks that we've been given in this lab configuration. So first thing first, what we're gonna do is, so first thing first, so we're going to configure the ACM1 to become an eBGP pair with ISP entry 1. So ACME as a AS autonomous system number is 65001, and the ISP is using the AS of using number of 65003. So we're going to use 1.1.1 as the neighbor IP address and add to it. So there we go. Let's make this and conf t. Oh. So we're gonna do router BGP 65001, right? And then the neighbor IP address, so the neighbor IP address is that 1.1.1.1 as we've been given. So that's this IP here. And one, then the remote as 65003, right? 03. So that's what we've been told here. So, and now, from any device inside of the ACME network, we can ping the other company entitled server. And if we done that, it will not work right now. So in part 2 of this configuration, we're going to configure the eBGP for other companies' INC. So the network administrator, so we have to, we're not if you're not familiar with BGP and could not configure the other company side of the link, because of this, you must also configure the other company ends of the connection. So we're going to configure order C, this order C. So which is this one here. You have to configure this router to form an eBGP adjacency with the ISP entry 2, which is the ISP border router facing the other company C. So other company C is under the AS65002, while the ISP is under AS65003. We're going to use, so let's go ahead. And then we could do router BGP 65002. That's what we've been told, right? So that's what we've been told. So 65002. Then we have to do neighbor. So neighbor. So 1.1 up. 1.1.9. That's what we've been given. Then the remote as have to be 6500.0.0.3. So it says it's up. And then we have to put a network. So IP, check. So it's this IP. Gotta copy it. And let's paste. Move this to 3. And the mask to be 255.255. 255.255.0. Okay, so now in this step, we're going to verify the eBGP. So what we could do is to exit out one, let's say do show IP BGP some. So you see here, so the neighbor, the IP address, we sign. So it says the BGP router identifying 72.2.0.1, and the local AS number is that. The BGP table version is 5. Main routing table version is 6. For network entry. So let's try this command. Oh, sorry. Let's try this command into this router. It says do show IP BGP some. So if you look at this routing table on the ACME and the other router, you should have to learn the route to the other company network, which is 172.16.10.0/24. So it's similar to the same one. Now, if we open a browser, yeah, see, and navigate. Let's see here if we can ping. And 7.2.16.10. So we got it ping. So it says timeout. Now, about so we got a successful pin. Now let's try. Obviously, we should get a successful pin here too. You got a successful ping too. So guys, that's pretty much all that we have to do to configure those two routers well with eBGP. So if you have any question, you could always reaching out to us or leave a comment below. And if there's anything that we could do to improve these lectures and lab, so don't hesitate to tell us. We'll be more than happy to learn from you. Again, thank you. I appreciate you guys for following along. Thank you. Bye-bye. I'll see you in the next lab and lecture.